All right, so next we're going to look at composite functions. This says let f be a function of x into y, and let g be a function of y into z. Let x be an element of x in f, then its image f of x is the domain of g, and we can find the image of f of x under g, which is f of g of x. There exists a rule which assigns each element of x a corresponding element f of g of x in what? Which is an element of z. In other words, that rule is f of g of f of x. Now, the range of g is the domain of f. So someone could say that the composite function g of f of x is a function in which the range of f is the domain of what? G. Now, the function f of g of f of x is called a composite function of g and f, and is denoted g of f or g naught of f. So it's important to take a note of here g naught of x of f. That's another way to represent or to denote the composite function g of f of x. All right, let's have a look at example 30. Example 30 says, let f of x be equal to 4x plus 2 and g of x be equal to 3x plus 4. Then we're to find f of g of x. All right. So now f of g of x is a function in which the the range of g is the domain of f. In other words, in f, wherever I see x, I'm going to put g. F of g of x is a function in which the range of g is the domain of f. In other words, in f, wherever I see x, I'm going to replace x with g. So I'm going to write f all of a sudden, the pen started to give me a problem. So it's 4. Wherever I see x in f, I'm going to put g. So to find or to determine f of g of x, I'm going to write f. And in f, wherever I see x, I'm going to take out x and put g. Then I'm going to simplify. Distributive law, 4 3 is 12. 4 4 is 16. This is 12x minus 14. F of g of x is 12x minus 14. So that's A. B is asking us for g of f of x. Now, g of f of x is a composite function in which the range of f is the domain of g. So in g, wherever I see x, I'm going to replace x with f, which is 4x plus 2. And then I'm going to simplify. Distributive law, 3 4s are 12. 3 2s are 6. So g of f of x is 12x plus 2. All right, so next we're looking at example 31. Example 31 says the functions f and g are defined as f of x is equal to 2x plus 1, g of x is equal to 2 over 3x plus 2, where x is not equal to minus 2/3. We're asked to express in a similar form the function g of x and in a similar form the function f of g and g of f. So let's start there. Let's call this part A. F of g of x is a composite function in which the range of g is the domain of f. So in f, wherever I see x, I'm going to take out x and put g. All right, plus 1. So this essentially works out to be 4 over 3x plus 2 plus 1. I'm guessing we could leave it like that, but let's make it into a single fraction. 3x plus 2. 3x plus 2 into 3x plus 2 is 1. 1 times 4 is 4 plus 1 into 3x plus 2 is 3x plus 2. 3x plus 2 times 1 is 3x plus 2. So as a single fraction, f of g of x is 6. Sorry, let us say 3x plus 6 over 3x plus 2. All right, then we're also asked to find f of g of 2. Now, for f of g of 2, in f of g of x, wherever we see x, we're going to replace x with 2. So that's 3 times 2 plus 6 over 3 times 2 plus 2. So this is 12 over 8. The final answer here is 3 over 2. So f of g of 2 is equal to 3 over 2. All right, the B part of the question, we need to find g of f of x. Now, g of f of x is a composite function in which the range of f is the domain of g. So in g, wherever I see x, I'm going to take out x and put f of x. So that's going to be 2 over 3 times f of x, which is what? 2x plus 1. Plus 2. All right, I guess if I wanted to simplify it, I could say this is equal to 2. Down by the bottom, distributive law. 3 2's 6x, 3 1's 3, plus 2. And the final thing would be 2 over 6x plus 5. Then we're asked to find g of f of 3. To find g of f of 3, in g of f, wherever I see x, I'm going to replace x with 3. So this is 2 over 6 times 3 plus 5. This is 2 over 6 3 is 18. 18 plus 5 is 23. This is 2 over 23.